In this video, I'm going to show you how to make a flat joint. It's a complex jigsaw type joint, and I'm going to make it a little bit more fancy than the standard joint. But in that, I had some challenges. The amount of material matters because of vibrations, and you can see that there's a little bit of a sawtooth issue here. Getting the depth perfectly right is an issue. So this particular type of joint, you want to make the depths, because this is going to be two halves fitting together, you need to make the half depth perfect, and your spoil board needs to be perfectly flat and surfaced. Okay, let's get started. I'm going to start out with 4-inch pieces of wood, like last time, but in a flat arrangement. I'm just making a line and I'm offsetting it by 4. I'll make it a little bit longer so it looks a little bit more like a frame. And I'm going to mirror this at a right angle. A standard miter joint would look something like this. You can see it's generally just one line. With a more complex type of joint, we just want to take a line and sort of move it around and then meet back at the other corner. But you want to make sure that there's enough corners around here that allow it to be locked in place. For instance, say I'm just going to make a joint like this. You can see that the joint is here, but it doesn't really do any locking. You could still pull it apart. Let's go back to the other form and let's get a little bit more drastic here. Now, this type of joint, you can see that you'd be able to lock it in place. You wouldn't be able to tear it apart. And from here, you'd need to consider the size of the bit that you're using. So we're using a 1/4 inch. So you'd need to make the radius of all of these corners at 1/8 of an inch. And there you have a general joint. But there are a couple problems with this joint, and I'll show you why. If you draw these lines, you'll see that the joint exceeds or goes across a boundary that we don't want it to. Because if we have just a straight piece of wood, we wouldn't be able to get this material all the way to the outside of this particular line. So we need to work within this square. So let's remove this. And I think we can do better than this anyway. There's a lot of designs that we could create that add an attractive feature to the corner of the wood. Let's go ahead and put these other lines in here so we know where our boundaries are. And I'm going to create just a simple X pattern here. Let's experiment with this a little bit. I'm not sure I like that. Let's go with a circle. Let's take the circle and mirror it. Yeah, that looks good. And then mirror it on the other side. And we'll take tangents. Let's get rid of some of the lines because it's confusing me a little bit. We know these corners are going to need to be rounded for the size of the bit. 1/8 of an inch. And then I'm going to take this one, round it out here, and then this one is going to be rounded over here. I'm going to use 0.5 for that. Oh, that's going to be too big. 0.25. And then just connect these. And I'll round these out. But we can see that there's a little bit of room. The end mill would have to be able to get through this area, cut all this stuff out, and then leave all of this material here, and then the opposite on the other piece. And also this piece looks like it's really brittle, so it could break easily. So we'll increase the radius of the radii of these curves, and then also with this one. I'll start with these two since these are the smallest. Well, actually they're all the same, so I'll start with this because it looks like it's a tighter corner and it could use a little bit more smoothing. Doesn't look like it went enough, so I'm going to try it again. I'll try 1. No, that's going to be too much. 0.75. That should work. And then I'll increase these a little bit more. Now this looks like a joint we can use. It looks like we made sure that it doesn't go outside of the boundary. I'm going to erase that. Erase this one, and that's what the joint will end up looking like. So we're going to create 2 pieces from this one. Just make a copy, and I'm going to generate both of these pieces like this, but I'm only going to pocket this piece halfway through the wood. But this one will be halfway on the underside, so I have to make a line here. And I have to mirror it because the CNC machine, since it's only 3-axis, it's going to be able to do the pocket from the top. So I'm going to mirror this. This way I can remove all of this material halfway down the wood. This will be the full wood thickness, and this would be the full wood thickness, and this part here would be the half wood thickness. So this would be able to marry itself very easily into this portion. In the last video, in the finger joints, I used a 0 tolerance between this line and the other line, or the fingers. In this case, because there's so much geometry, I'm going to want to create more space between each piece, the puzzle piece. This puzzle piece, because this has more surface area for this portion of the wood to use for structure, I'm going to make this one the tolerance. I'm going to offset this geometry and make it smaller, so when this geometry fits over it, it should fit nicely. I'm going to try 5/1000ths of an inch. Not 5/1000ths, but 5/1000ths, which is half of 1/100th of an inch. This looks like it's really a small amount. I'm actually going to increase it to 1/100th. I'm not sure what I'm going to get, so I'm going to do a test at 1/100th and see what happens. Actually, I just noticed I'm going to have a problem right here because I'm making this circular area smaller than the bit is, so I'm going to have to make that a little bit larger. I'm going to delete these first, and I'm going to have to do that to both of these. So I'll make it 0.2. Yeah, that will work. Okay, I'm going to get rid of the original line that was there. Actually, I'm going to make this a polyline so I'll make them both polylines. Okay. I don't want to have these lines part of it. Okay, so this one is 1/100th of an inch smaller than this one here, or offset. I'm going to put this back on here to see what it looks like, and see how I can treat where this ends up and this one does. So I'm going to turn this one into a block. I'm going to mirror it, move it right back where it was at that corner. So we can see this is the difference in space that we have from one to the other, and everything looks like it's right and offset. So I think I'm just going to want to trim this off here. That should be fine. And this one, I think I'm going to trim it like so. Actually, I may not be able to do that with CNC, so I'm going to extend it. That way I can create some kind of pocketing that goes outside of this line, and it makes sure that it gets a good corner here. Okay, I'm going to delete this, and I'm going to create a polygon here that represents this pocket. But I also want it to go outside of the bounds when I'm pocketing, so I make sure that this is a nice corner around this edge. I'm going to use the BO command, which is the boundary command, and this is a really, really cool command. It creates a polygon boundary. You can see it made a nice polygon just by doing that one command. I'm going to make a little bit of space here, and I'm going to break this up or explode it, and I'm going to offset this to the size of the width of the bit. I probably only need to go half the width because I just want to make sure that it gets to this point. I'm going to get rid of that actually. I'm going to offset it 0.125. Yeah, I don't think it would hurt to go a little more. I'm going to go 0.2 just to make sure. I'm going to take a half circle and I can get rid of this line here. Look at that, that's why I didn't extend all the way. So my bit will go all the way out here and create a nice corner, and it'll make sure that it gets all of the edge. I can round off this corner here because it's in an inside pocket. This is an interesting case. I could extend this and then extend this line as well, so it meets up with this line, but I'm just going to do a larger circle from this point. On second thought, I'm going to undo all of that because I want to go out full width of the bit, because I just realized it won't fit inside that area. And I'm going to go ahead and extend this all the way here. So offset 0.125. Oh, I'm sorry, 0.25. Now my circle. Okay, this looks better. Although okay, I'm going to make this back into a polygon. I can move any one of these points back. There. Okay, so it'll pocket all of this out, and then it's going to, I need it to also pocket this portion. So I'm going to do the same thing. And I'm going to do a similar task to this one. I'm going to make a boundary hatch, or a boundary polygon. Break it up. Break. Explode. Alright, offset 0.25. I'm just going to do it to these on the edge here. And just make sure that the inside corners, actually I won't have any inside corners. Offset. Got this one here. These can go ahead and be corners because this is an outside corner. And that one I can't do. Offset. I'm gonna get this line down here. Okay. Make a circle on this side. Okay. Turn it into a polygon. Join it all up. And move it back into place. So this will be my pocketing for the underside of this piece here. Actually, I may have to do it on this side too, so I'm going to break this again or explode it and get rid of this. And I'm just going to do let me get that back. Do a 0.25 radius circle around that, and then a 0.125 here. It should be able to get a nice corner in at this point. That's not where I want it. There. I almost lost my position, but I still have this one here, and this was a 0.125, which is half of 0.25, so I just moved it over another 0.125. So now this is positioned correctly, and now we're ready to create the boundaries for the actual profile to cut out the piece. So I can get rid of that line that I have here, if I have one. Do I have one? Yes. I'm going to explode this one, get rid of this because I don't need that anymore. I need to be able to cut this out. I'm going to put a line here. I'm going to rotate everything so it's in alignment. Can save material. Oh, let me join this first. P-edit. Okay, get it to closed polygon. I need to do the same thing with this one. And this one we only need to cut out the square because we've already pocketed this portion out. So we just need to cut out this square, and looks like we already have one. I'm going to... That's interesting. I have something here. We'll replace this with a rectangle. Maybe not. Alright. Now I've got a rectangle. I don't really need this information here, so I'm going to delete it. Actually, I'm going to first move my pocketing in position. We can now save the file and go into our CAM program. Okay, let's go ahead and start up Kanban. Let's load saved in documents. There we go. Okay, We can start with creating the pocket for this piece here. Select the polygon and use the pocket machining operation. And now we have to figure out the target depth. And I have to go and measure the actual thickness of the wood that I'm going to be using. Okay, the piece is 0.76. So this needs to be half of 0.76, which is 0.38. So my target depth is going to be 0.38. So it'll only go 0.38 down, and I'm going to do the same thing with this one, but let's first cut this out. After I inspect all of this, looks good. Okay, so I'm going to profile. Actually, I'm going to do 2 passes here. So what I'm going to do is, I could do I'm going to do a profile, inside profile on this one. And it's going to be a finishing profile. So it'll be right on the line. But this pocket, I want to make it a little bit off. So it's going to be a roughing pass. So you can see that it won't go all the way to the edge. So the very last profiling will skim off the edge just a little bit. So it'll make it really nice and precise. I also have to make sure that this profile is 0.38 and check to make sure that's correct. Yes. So now I'm going to do an outside profile, 2 of them, one for finishing and one for roughing. Now I'm ready to do the profile for this, or the pocket. And this is also going to be 0.38. And the pocket will also need to be roughing. Then I'm going to do an inside profile for finishing. This one also has to be 0.38 depth. Yes. Okay, now all I need to do is do this outside profile and we should be done. So a roughing and a finishing pass. I think we're ready to put this on the machine, so produce G-code and run the machine. So here are the pieces that came off the machine. You can see the way it was pocketed so it can lock in together. It looks like that I haven't made enough of a tolerance allowance between the two. It still can't lock together, but if I add another 1/100 of an inch around, it should work fine. Okay, I've just finished the runs on my CNC machine. This is the first one I did, and it has a tolerance of 1/100 of an inch. And you can see that it's also not level because I didn't go deep enough on the pocketing. And it was really hard to get this together. So what I did is this is my first test, and it's a challenge to get it to the right tolerance. So I did another one, and this is at 2/100 of an inch. And really I'm just taking one side down 2/100 of an inch. This one isn't affected at all, just this one. And it is essentially 1/100 and 1/100 if you think about it as a tolerance on both sides. And it slips in pretty nicely. There was an issue I had right here, and it's because I made this portion of the design too small. It wiggles a little bit, and when you have it in the machine, it's going to start vibrating, and then this kind of thing will happen, where you have a sort of a sawtooth look because of the end mill running around and it's vibrating and causing this thing to vibrate pretty violently. So let's see if it fits. And this one I also went a little bit too far in the depth, but my machine, I didn't do any spoil board surfacing. There you go. You have the Jigsaw miter flat joint.